Hello everybody, we're getting ready to do 6.2 for a SAT Math Level 1 prep, which is a geometry lesson about finding area of plane figures. Contact me here for materials. 6.2 area of plane figures, this is part 1. You got a 62-point skill check after this PowerPoint, which you can get from me at that email. And then your notebook, your note-taking guide, you can also get if you email me. 42 points of notes here. Overview of this section. This lesson reviews some key properties of parallelograms, as well as formulas to find the areas of parallelograms, trapezoids. So, properties of parallelograms and rectangles. A parallelogram is a quadrilateral whose opposite sides are parallel here. So these are parallel and then these are parallel. In addition, opposite sides have the same length. AB equals CD and AD equals BC. Here AB equals CD and then AD equals BC. Yes? Opposite angles have the same measure, so AD is parallel to BC. So these angles here are similar, congruent, and then these angles here are congruent. A rectangle is a parallelogram with 4 right angles, so we have 4 right angles here. A rectangle has all properties of a parallelogram, and the additional property of that is diagonals have the same length. So for rectangle, these are the same length, ACD, etc. So area of a parallelogram and a rectangle. Area of a parallelogram, area of a rectangle. Here is our base here. Here is our height of a parallelogram. HB, area equals BH, area equals BH. So they have that similar. Thing is here, you got to figure out your height on a parallelogram. To find the area of a parallelogram A, B, C, and D, draw a perpendicular segment BH as shown here. So they go from this vertex down to base. Since BH is the side opposite of the 45 here, in a right triangle, H would equal 6 times square root of 2 over 2, which equals 3 times square root of 2. Opposite sides of parallelogram are equal, so AD would equal 8. So the area of this parallelogram will be B times H. We know B here, and we also know H. AD times H, so AD times H. 8 times 3 times square root of 2. We get 24 times square root of 2 for the area of that parallelogram. To find the area of rectangle ABCD, we have some dimensions here. Note that the diagonal forms a 5, 12, 13 right. The width of the rectangle is 5, so the area of this rectangle will be length times width, which should equal 12 times 5, 12 times 5. Area of a rhombus in a square, area of a square, area of a rhombus. Here is a square. Here would be a rhombus here. Area is 1/2 D, capital D times D, so it'll be 1/2 of D times D here. Area will be S squared, so area will be 1/2 D squared, 1/2 of D squared. Diagonals of the square have the same length. In both the rhombus and the square, the diagonals are perpendicular bisectors of each other. So it'll be 1/2 of D times D in this situation here. Area of a rhombus, ABCD. Here is a rhombus here again. So if rhombus ABCD has a side length of 10 and a longer diagonal measure 16 here, this is 16 here, then the shorter diagonal measures 12 since diagonals AC and BD are perpendicular to each other. These are perpendicular here and bisect each other, so we know that much. Makes triangle AED, a 6, 8, 10 right triangle, 6, 8, 10. So BD here would equal 12. Area of a rhombus of ABCD would be 1/2, 16. 16 times 12 would be 96. So we have this 16 here and this 12 here. So it'll be 1/2 of both your diagonals multiplied together gives us 96. Area of a triangle, right triangle, and an equilateral triangle. Here is a triangle, right triangle, equilateral triangle. Area equals 1/2 base times height. Area equals 1/2 base times height. Area equals s squared over 4 times the square root of 3 in this situation here. Unless we divide it up into two. So find the area of this triangle here. The lengths of the sides of triangle ABC form a 3, 4, 5 Pythagorean, where AC equals 4. So AC, this would equal 4 here. Area of triangle ABC, 1/2 base times height, would be 1/2 3 times 4. 1/2 3 times 4, this is your height, would equal. Find the area of triangle JKL. So we have JKL. So we can figure a height here. Drop a perpendicular segment from vertex J to side KL. Extending it is necessary since angle JKH measures 30. Height would equal H, would equal JH equals 1/2 times 12 here. So H here, height would equal JH, height of JH would equal 1/2 times 12 here. 1/2 times 12 would equal 6. Area of JKL would be 1/2 base times height would be 1/2, 8 times 6 would be 20. Area of a regular hexagon. Regular hexagon can be divided into 6 equilaterals here. So we have 6 equilateral triangles. Since the area of each equilateral is s squared over 4 times square root of 3, the area of a regular hexagon is here, 6 times this formula. Then we just plug in the side length and we have it. If the area of a regular hexagon is 96 times square root of 3, what is its perimeter? So we have this situation here equals 96 square root of 3. So if we solve here, we're going to solve here for s. We need to know the side length. S squared equals 64, so s would equal 8 in this situation here. So the perimeter of a regular hexagon would be 48. And then we have an area of a trapezoid is quadrilateral for the pair of parallel sides. So here are our parallel sides. The area of a trap is the altitude times 1/2 of the sum of the lengths of the two parallel sides called bases here. So area equal height times 1/2 capital B plus B. Isosceles trapezoid, non-parallel legs. Sides or legs, non-parallel sides, legs have the same length, and the bases and the angles have the same measure. So these base angles here are similar. So find the area of this trapezoid here, ABCD. Use the fact that the lengths of sides of the right triangle. We have this here, 13 and 5, and we don't know what that is yet. Is a 5, 12, 13 Pythagorean where height is 12. The length of the lower base is AD is equal to AE plus ED equals 5 plus 27 equals 32. So the area of a trapezoid, here's our formula here. Height times the sum of the bases over 2. So BE, here's our height times AD plus BC, AD plus BC equals 12 times 32 plus 18 over 2 would be 300 here. And then find the area of this trapezoid here. Area of trapezoid ABCD is height times the sum of the bases over 2. So we divvy this up into a rectangle. BH here is our height here. Our height is BH times AB plus CD over 2. So what is that? So it'll be 15 times 10 plus 18 over 2, 10 plus 18, 10 plus 18 over 2. This would give us 15 times 14 would be 210. If you want more PowerPoints, you want your own PowerPoint or video of the whole course, email me here. I give online tutoring, I give tests, worksheets, etc. Email me. Thank you.